Hello everyone. In this session, we are going to start the second unit, and it is having two parts. And it is some of the concepts are repeating from the first unit. So, in this session, we are going to discuss about the machine learning and its limitations. As I mentioned, there are two parts. First part is the practical approach for the artificial neural networks, and the second part is the introduction. So I'm going to start the second part first, and then I will go to the first part. In this, building the intelligent machines, for that, this is the first topic, and it discussed about the brain, meaning that in our human body, the brain is the most incredible part, and it can have the five senses, and it can take the signals from the five senses like sight, sound, smell, taste, touch. All these are the five senses. Based on these five senses, it takes and it analyzes and it can take the decisions, and it can give the instructions to other parts of the body. So it is very powerful, and it enables us to store the data, meaning that we can memorize the whatever you have seen, whatever you listen, and experience the emotions. It can recognize the emotions, and all these are possible by the brain. Even the infant brain means a small kid, baby. A baby brain is also, it may have a single pound, but it is more powerful than the supercomputer. It can see, it can recognize, it can listen, it can watch, and it can feel the touch. The baby can feel the mother touch. He can recognize the mother touch. So when he grows, the months going on, then he can recognize and he can understand more. It is not possible for the supercomputer also. And for the number from the number of decades, we are trying to reach that level of recognition and the performance by using the computer. To tackle these type of problems, our regular programming, computer programming languages, they are not suitable and they are not sufficient also. But we should have some other level of the computation power and other level of the algorithms. So artificial intelligence is the field which can deal with these type of problems. And the limitations of the traditional programming, as we discussed in the first unit, it can perform the arithmetic and logical operations very fast, and it can perform it can follow the given instructions exactly. So the accuracy is also very good in the computation in the regular traditional programming, but it is not suitable for some of the problems like the handwriting recognition. In the handwriting recognition, the persons may write the different digits in different ways. If you observe that there is the difference, it is difficult to identify the difference between the 3 and 5. If you see that here, you can observe that in this situation here, you can observe that here at this place, the 3, it is looking like the 3. Actually, it is a 5, but it is looking like the 3. So the human brain can understand, but the computer cannot understand these kind of operations. So we should have some special kind of intelligence. So that is the artificial intelligence and machine learning. As a part of the artificial intelligence, we have the machine learning, and as a part of that, we have the deep learning also. So to tackle these class of problems, we should have the different kind of approach that is called the by seeing the examples. By seeing the examples, it has to recognize, it has to understand the situation, and it can identify and it can build the rules. Let us say, for example, if you want to teach a small kid to recognize the dog, instead of explaining the dog has four legs and one mouth and one tail and one head, two ears, like this, instead of explaining like this, if you show the picture of the dog, and then if you say that this is the dog, and if you show the cat picture, and if you say that this is the cat, so that he can recognize more nicely. So that if you show the 10 pictures of the dog, he can recognize the 11th picture easily, whether it is a dog or not. And if you, meaning that if you increase the number of examples and the number of experience, if you increase the experience, automatically it can increase the performance also. So that is called the, internally he will build the model that he will train the brain that he can recognize with the given examples. So the deep learning is the subset of the artificial intelligence as we discussed. So the deep learning can handle the complex problems. So the machine learning, what it will do is, it will have a model and it will evaluate the examples and it will modify the model based on the evaluation of the existing model, so that it can modify the parameters that we can represent in the coming slides. Now we can say that we can define a model, machine learning model, that is by using a function h of x comma theta. X is the input here and theta is the parameter, and here x is the input vector. The input can be only in the form of the vector. So for the regular tabular data we can give that in the vector, but how can we provide the data as the vector for the image data? If you see that here there is the image with 4 by 4 pixels. In the 4 by 4 pixels, this is the black and white picture. White is representing with 0 and black is representing with 1. So gray is representing with 0.5. So I want to represent this image pixels into the vector, so that first column can be taken as the first 4 values, and then the second column will be taken the next 4 values, and so on, so that it can be represented in the vector form, so that this image can be represented in this vector form, so that we are getting the vectors. And of course the theta is the parameter. The parameters will be designed, the parameters will be created one per the input variable. So if you have 5 input variables, 5 parameters are required. So now let us have the let us see the example of the prediction of the exam performance of the student by depending upon the number of hours of sleep and number of hours of study. Now let us see the example. Number of hours of sleep, we will take that as one input, and number of hours of study, that we are taking the second input. So that will be taken as the x. See here, x equal to x1 and x2. We can give that as the transpose, for this is for the multiplication purpose, and we can do that. And the output is the -1 and 1. -1 represents the below average and the 1 represents the above average. So these are the input and outputs. So for these inputs and outputs, we have to provide the parameters also. We have to define the parameters also. The parameters will be represented with the theta. Since we have the two parameters x1 and x2, we should have the theta1 and theta2. Theta0, it is for the bias intercept. We can call it as the intercept or the bias. So we can represent the h of x comma theta as mentioned in the previous slide. H comma theta equal to -1 if x into theta1 theta1 and theta2 plus theta0 is less than 0, then we can classify that as the -1. If it is greater than or equal to 0, then we can represent this as 1. So that we can represent, what we can do is, here the x is not in our hand, x is fixed input, and the theta is in our hand. This is our parameter. So we have to tune these parameters to reach the to perform well for classifying these two based on the x and theta. So we can say that the theta can be modifiable, so that I am taking the values of theta as -24, 3 and 4. So here initially I am taking these three, so that how can we calculate with the existing examples is h of x comma theta equal to -1 if I am just substituting the -24, 3 and 4. -24 is at the place of theta 0, 3 is at the place of theta 1, 4 is at the place of theta 2, and so in this 3x1 plus 4x2 minus 24 is less than 0, then it is minus 1. If 3x1 plus 4x2 minus 24 is greater than or equal to 0, then it can be the one that is average, above average. We can say that it is above average. Now, the model, whatever we discussed till now, that model is the linear model. Why? Because we can separate the problem in the linear fashion. See, we are having the simple expression we are taking, so that it is the linear model. So that if you take the linear model, x1 and x2, these are the x1 and x2 parameters, and all the minus values or negative values are here and all the positive values are here. So by using a straight line, you can classify, you can categorize these two into two parts. See here, if it is the less than 0, then it will be the minus 1. If the value is greater than 0, then this is the value for our equation, whatever we have given the equation in the previous slide, that is here, this slide, this equation. That equation line is this one. So if it is less than 0, then it will be considered as this, and it is greater than 0, then we can consider that as the positive. So this is a linear relationship and linear classification. And in the most of the cases, it may not be in the linear. In most of the cases, it may be in the non-linear also. Even if it is in the linear, what we can modify is, we can modify the parameters. These parameters here, initially we have given these parameters, but by seeing the number of examples and time goes on, we have to modify these parameters. How to modify them? Who will modify these parameters? That is by using the optimizer. The optimizer aims to maximize the performance of the machine learning model by iteratively tweaking its parameters, that is theta 0, theta 1, theta 2, until the error is minimized. So that we have to modify the parameters, parameter values, and we have to continue the iteratively, and we have to process that till we get the minimum error. So definitely there will be the error. In the machine learning or in the deep learning, we will not get the 100% accuracy. At least there will be the 0.0001 error will be there. So it is completely approximate values only. So and of course, in the real-time examples, the relationship may not be in the linear; it may be in the non-linear fashion. So that if you take this, see here, this is the curve, meaning that by using a curve we can separate these two values. And in this situation, we can separate the categories by giving the circle. Of course, we are seeing this. If you see that front side we have the plus and back side you have the minus, and from the front view you are seeing, so that all these are in the same plane. So if you increase the dimension, all the plus will be on the top, minus will be on the bottom, so that you can separate that by using a plane. So that if you increase the dimension, there is the possibility of classification more. And if you see this classification, this is also another important thing, and it is also another multi-dimension dependency data. So that for this also we should have the complex architectures. Based on the relationship between the data elements, we have to choose the complexity of the model. So deep learning, it can deal with these type of situations by using the artificial neural network. Thank you.